5 broad areas of physics that I think you should know a little bit about: classical mechanics, energy and thermodynamics, electromagnetism, relativity, and quantum mechanics. Classical mechanics is probably the most pertinent to your everyday experience. Here we have to introduce the father of classical mechanics, Isaac Newton, arguably the greatest scientist of all time. There are 2 main concepts worthy of remembering. The first is embodied in Newton's second law: force equals mass times acceleration. This is a deceptively simple equation that has some huge ramifications. Force in classical physics just means a push or pull. Mass is a measure of inertia, how much something doesn't want to change in motion. Acceleration is how rapidly your velocity is changing. If you apply a force to a fixed mass, it tells you how much acceleration you will get. And knowing acceleration, which is the change in velocity, you can make predictions like where an object will be at a certain time and space. So with this simple formula, for example, I can predict exactly where this basketball is and where it's going. If I know all the forces acting on it, including the friction of the air, which is also a force, I can predict exactly whether or not it will go through the hoop. This same formula can be used to determine how much reinforcement you would need to build a bridge and how to calculate the lift of a rocket. It's an extremely powerful equation. Force is not a material thing. It is a measure of interaction. Your body does not have a force, it has a mass. Your weight is the force your body exerts on the ground. Technically, you don't weigh 80 kilograms because that's your mass. You should be saying you weigh 784 newtons, which is your mass times the acceleration of gravity on Earth, 9.8 meters per second squared. To give you an idea of scale, 1 newton of force is equivalent to the force you would feel on your palm if you were holding a small apple. The second equation, also from Newton, is the law of universal gravitation. It allows us to determine the motion of heavenly bodies, like the moon orbiting the Earth, or planets orbiting stars. It basically says that the gravitational attraction between 2 bodies is the product of their masses divided by the distance between them squared, times a constant, called Newton's gravitational constant. It tells you that the gravitational attraction diminishes rapidly as objects move apart because it's proportional to the inverse of distance squared. This was a revelation when Newton formulated it because it explained mathematically the movement of all heavenly bodies. It still works well today.